Although we thank you for it. We thank you for attending the new with us to be here. We thank you for our facilitators and for this gathering. We thank you for this program and we thank you for what we know you're going to help us to develop. We pray that you mentally prepare us, socially, physically, and health to be an interactive session. Help us to benefit and gain from the session. Both the facilitators and us students with very transparency and have no challenges or problems for further. I wish you a good development and bless everyone in this room. Just now. Amen.
Okay, amen. Thank you. Okay, thank you so much. Today, the topic we are going to look at is going to be a topic called trigonometry. I know some of you have covered, some of you have heard about that topic of trigonometry, but depending on what you wanted, I went on and took the biggest percentage wanted us to review two concepts in trigonometry. And one of those concepts was on what we call the cosine rule. And another concept was on what we call the sine rule. So those are the two things that members wanted us to look at, what we call the cosine and what we call the sine rule. And then members suggested that next week we shall continue to cover another topic. So next week we shall look at matrices, of which I think many of you have not yet looked at matrices, but that one we shall cover it next week. But today, our major part of concentration is going to be on what we call the cosine rule and what we call the sine rule. However, to give a brief on those who have not yet met what we call trigonometry, when we talk about trigonometry, the word tri is a Greek word, which means three. And inside the word tri, we have what we call gonometric, which means angles. So here we are basically looking at what we call the three angle measurements. So when we talk about trigonometry, we are looking at what we call measurements of angles, calculations of angles, and finding the sides of different triangles. So in trigonometry, we mainly look at angles. And which angles do we look at? So we are mainly going to be looking at what we call sine, what we call the cos, and what we call the tan. So in the trigonometry, we have three important ratios. One of them is called a sine, another one is called a cosine, another one is called a tangent. And in order for you to be able to know what trigonometry is briefly about these three important things: what we call the sine, what we call the cos, and what we call the tan. And whenever they talk about these three important things, what has to come to your mind is, how are they related? So the sine, the cos, and the tan are related using a simple acronym, what we call TOA. So those who have not covered trigonometry at all, this is the acronym we can use to remember the three. S stands for the sine, and S standing for the sine, it shows us the relation. So these three important things, they are the ones that show us the relation that is existing between the different sides of a triangle. Whenever I have a right-angled triangle, let me say this is my right-angled triangle, and maybe I have an angle theta here. The side that faces where the angle faces is what you call the opposite side. The side where this angle sits is what you call the adjacent, and the longest side is what you call the hypotenuse. So these three sides are related using sine, cos, and tan. So whenever I want to find out what is my sine of any angle theta, so sine of this angle is given by O, which is opposite out of hypotenuse. When it comes to C stands for cos. So cos is given by A out of H. And A stands for what we call adjacent. So cos is given by adjacent out of hypotenuse. And when I go to T, T stands for tan, which is tan of the angle, which is given by O divided by A. So that means I'll have the opposite out of the adjacent. So when you are dealing with trigonometry, anyone who has not done anything concerning trigonometry, these are the important things you need to know, that sine, we give it as opposite out of hypotenuse. Tan, we get our opposite out of adjacent. So in case I use this triangle here, when I have that triangle, let me say, this is maybe theta, this is 3, this is 4, and this one is going to be 5. When they ask me to get sine theta, it means I'm going to come, I look at my opposite. We said our opposite is this side. So I will say my opposite, that is 4, divide by my hypotenuse, which is h, and for this triangle here, I have 5. So that is my sine theta. In case I want to find my cos theta, let me see whether people are following. So we have said cos theta is adjacent out of hypotenuse. Can someone tell us what would be our adjacent for this triangle?
3.
3, very good. Divide by what is hypotenuse?
5.
5.
Let us go to tan. What will be our tan?
Tan is 4. No, it's 4 out of 3.
4 out of 3.
3.
Now I'm taking, because I want us to be on a neutral ground. So I want us to be on the neutral ground. So that is a brief. Those who didn't have any idea concerning trigonometry. So that is how you find it. However, to go back now, I want to take you to another part. Another part is that how do we, okay, I think that is briefly about, but now for the next part, I know you'll be able to make a follow-up on what will be taking place. Okay, now we are going to continue and look at what we call the cosine rule. Now, when we talk about the cosine rule, we are looking at two important things. One is the relationship between the sides and the angle being formed. And what is a cosine rule? A cosine rule is that rule that is going to help us to find the length of the different sides of the triangle. It is that rule that is going to help us to find the angles inside the triangle. Some of you have been meeting triangles that are not right angle triangles, and you have been wondering, in case that I'm given here 3 and it is 5, how can I find this side if this triangle is not a right angled triangle? And that answer can be answered using the cosine rule. You have been meeting triangles whereby they have given you an angle 30, and you don't know how you can find the remaining angles when this one is not a right angled triangle. So the only way to do it is through using the cosine rule, or what we shall use the sine rule. So such figures of which you are not sure whether it is a right angled triangle, whether it is a scaling, whether it is this. So in order for us to be able to calculate the length, to be able to calculate the angle, is where we apply the cosine rule. And how does the cosine rule come about? In order for us to come up with a cosine rule, one, you must label your sides of the triangle very well. And how do we label the sides of the triangle? We label the sides of the triangle depending on the letters we have at hand. Take an example. When you look at this triangle, it has 3 digits. It has A, it has B, and it has C. So when you are labeling your triangle, always you look at those sides and you label them very well. When you see a capital letter stands for an angle for that particular side. And when you see smaller letters, so let me say A, the smaller letter of A is this A. When I look at B, the small letter is this B. When I see C, the small letter is C. So these small letters, for them, they stand for the length of the sides. So whenever you find those small letters under cosine rule, they stand for the length. The capital ones are the ones that stand for the angle. So, however, when we are naming for any sides of the triangle, then we always look at the angle where it is facing. Now, for this side, our angle is going to be B. So the side where this angle faces, this side here, the length, we shall call it smaller b. When you look at this angle here is A, the side where it is going to face, that side we shall call it smaller a. So the length from here up to here is what we call the small a. When you look at C, C is here. So the side where it faces down, this side is what we shall be calling the C. Members, have you understood that?
Yes, teacher.
Now I'm going to give you an example and you label for me these ones here. I have capital P, I have capital Q, I have capital R. Members, can we label together? Which side is this going to be? Which letter shall we put this side?
Small r.
Small r. Very good. What about this side? Yeah.
Small p.
Small p. What about this side down?
Small q. Small q.
Very good. Very good. Let me hope everyone has understood that part.
Yes.
Okay. Now, first, let me first select this. Briefly. Okay. And I'm going to go back. Now, how am I going to derive that relation? At this level, you may not need to know how. Oh, some people are talking. Okay. So you may, what do we need? We need to know always mathematically. Always a mathematician, you need to know how do those things come about. Not just to cram, but you need to know how do they come about. And this is how they come about. In order for us to be able to come out with that relation, we are going to first draw a perpendicular. We drop a perpendicular. And how do we drop that perpendicular? That perpendicular is going to come from C and it will meet at AB. So I have dropped it. So I will draw a line from C to come and meet my point, line AB. So this is my perpendicular. And the perpendicular makes up a 90 degree. Secondly, I'm going to go on and I drop something and I call that side A, that one A, B, and the last one is going to be C. Now, what do I want you? I'm going to take back one step. Now, what do I want you to know? Like we have said that when we are labeling these sides, we always look at the letters. So this side here is what we call our C. But since I want to find or to form right angle triangles, I'm going to assume that from here up to here, there is X. And members, if from here up to here, there is X, I'm going now to find out what is going to be from D to B. Imagine I can use this. From here up to here, there is 8. If from here up to here, there is 5, what will be the distance from here up to here?
3.
3. How are you getting 3?
8 minus
8 minus 5.
8 minus 5.
5.
Now, members, are you noticing from A to B, there is C. But from A to D, there is X. So what is going to be the distance from B to D?
C minus X.
Well, that's a book.
Are we together on that point?
No.
Yes.
Yes. Okay.
I think that.
So now I'm going to continue to the second one. Now, in order
We
for
check, they
us,
might have sent us the book.
okay, in order for us to be
I
able
check from here.
to find out
You
that
have to click
division,
on it.
I'm going to use what we call the Pythagorean Theorem. And when I'm using the Pythagorean Theorem, I'm going to extract my triangle A, C, and D. So I'm going to first extract that triangle. My triangle is like this. Here I have B, here there is A, this is C, and this is D. Here there is H, and here there is X. Anyone who remembers the Pythagorean Theorem, and you state for us how it says?
Yes.
What
A
is it?
squared plus B squared equals to C squared.
If you want to give an answer, please raise your hand.
Okay.
Okay, So what is going to be our A members? Okay. Yes, Ruth, I'm saying someone, Kasumba.
Our A is going to be X.
Okay, very good. Plus what is B?
Our B is going to be H.
We shall have H squared is equal to what is our C?
Our C
Priscilla?
is going to be
Priscilla?
RC is going to be B. B squared.
Very good. Now, that is going to be our first.
Mr. Kaziva,
Yes.
in the chat,
Mm.
there is a question from Joanne. She is lost. She's asking, where does X come from?
Oh, where does the X come from? Now, X is just like we have just assumed that the length from A to D is X. So this X can be any letter of your choice. Yes, X can be any letter of your choice. You can decide to use X, you can decide to use Y, you can decide to use Z, any letter of your choice, to assume the distance from A up to D. The only distance we are sure of is the distance from A up to B. So Joanne, this distance A to D can be any of your choice. But it is just representing the assumption that we don't know the distance from A up to D.
Kasumba, your hand is still up. Do you have a question? Okay. Patrick is also lost, but he's non-specific. Let Patrick raise your hand. Let me see. Where are you lost from? Okay. Maybe you type in the chat. I'll read out.
Okay.
It's okay.
Okay. So now this equation here, I can write it as that B squared is the same as X squared plus H squared. And I'm going to call this one our first equation. Now I'm going to go to the second thing, is finding the angle. Now, when I'm finding that angle, I'm going to ask myself, if I want to obtain, since we have talked about cosine rule, meaning that we are going to be mainly using cos. And you remember our first slide, we say that cos is given by adjacent out of hypotenuse. So when I come here, I'm going to ask myself, what is cos A equaling to? Can we have someone to tell us, if I want to obtain cos A, what is that cos A equaling to?
Victor?
It is?
X out of B.
He's saying X out of B.
Oh, okay. X out of B, because this is your adjacent. And this is our hypotenuse. Very good. Now I'm going to go on and I make my x the subject. So by making x the subject, it means I'm going to come here. I'm going to come here and I do something. To make x the subject, I'm going to remove this b. And when I'm removing the b, it means I'll have cos of a equaling to x out of b. So I multiply this side by b. I multiply this side by b. So this b and this one will cancel. So I remain with b cos of a equaling to x. And therefore, I'm going to write this very well. And I'm going to write it as x is equal to b cos of a. And I'm going to call this one my second equation. Members, let me know whether it is very clear. You can type in the chat and confirm that that point is clear. Is that point okay?
What am I saying? It is.
It is, eh?
Mm.
Okay. Okay. Ruth, have they confirmed that we can now continue?
Yes.
Okay, good. Now, those are the two equations we have formed. Now, I'm going to go on and look at the next one. Yes?
Mr. Kazia, sorry for the interruption. Joanne is still lost.
Joanne,
Let me first have her talk, because again, she's asking, what are we really finding? Joanne, please unmute and ask air out your question.
So what I'm really asking is the fact that you've said s squared plus b squared is equal to c squared, then where does this x squared plus the h squared equals to b squared come in? Even this first equation, the b squared, it's really confusing. I thought we should like place in the digits, then find, because are we finding the adjacent? Oh, that's where I'm lost.
okay, you keep on. Now, s squared plus b squared is the general rule that you know as the Pythagorean Theorem. Is that okay?
Yes.
Now, you knowing it, we are going to apply it on our question here, on our triangle A, C, and D. Is that fine? Now, when we are applying it on this triangle of ours, we must substitute what is representing A in the general Pythagorean theorem. So when you look at A here, which distance is representing A? That it is x. So where there is A, I'm going to put x. I ask, what is representing B? That B is represented by this height of h. So I put h. What is representing C? That C is represented by this side, which is B. So I put B. Is that okay?
Yes.
What
about this equation?
Which
the first
one?
Equation.
This one?
Mm.
And now the first equation is the same, is this one here. It comes from here. I've just brought the b to start, then I equated to this one.
Oh, but the fact that it is cosine, why don't we like leave it? Like we use the fact that the cos thing is equal to adjacent out of what? Why did we use this? Let us use this x squared plus h squared to ease the things.
Now, the general equation, now like we are coming up with the general equation. And in the general equation, we must have a cosine. In this rule to be called a cosine, it means that there is a cos in the rule. So that's why we are continuing with a cos.
Oh, okay. Hey, thank you, sir.
Okay. Now we continue. Now, the first triangle, we used A, C, and D. Now we are going to use the second triangle remaining. So the second triangle that is remaining is, let me draw it in a very good way. The second triangle that is remaining, it is like this. I have D, I have B, and I have C here. Now, D to B, I have C minus X, I have A, and I have H. Can we have someone, Ruth, to state for us the cosine rule for that? To state for us, to apply for us the Pythagorean theorem for this particular triangle. Someone? What is going to be our Pythagorean theorem? I want you to use Pythagorean theorem for this right angled triangle, and you tell us how is it going to be.
Kenneth?
It's going to be? Ruth, I'm not getting what you are saying. Okay, maybe someone. Oh.
Pardon, Kenneth. Okay, Kenneth's network is not clear.
What are they saying?
It's okay. Kenneth's network is not clear. Let's have Anzo Nelson.
H squared plus open H squared plus into bracket C minus X squared is equals to A squared is equals to A squared.
Very good, very good. Thank you so much. Members, kindly confirm that that part is very clear to you all. Please confirm in the chat that that part is very clear to you all. Anyone, in case you are getting any challenge with that part, let us know. Otherwise, we are going to move on. Is it clear, members?
According to the chat, it is.
It is clear. Very good. Now, I'm going to task everyone to type in the chat to expand for us C minus X squared. I want you to expand for us this one. C minus X all of it squared. Don't forget that you have to first say C minus X, C minus X. So expand and you put for us in the chat your answer first. Then we are going to get one person to do it for us in the class. Members,
Kasumba is lost.
Kasumba?
Kasumba, raise your hand and ask. Unmute. Kasumba.
Yeah, master, I stopped understanding your equation 2. Where have we got this h squared plus c minus x squared equals to a squared?
Okay. Kasumba, you seeing our triangle CDE?
Yes.
Okay. When you look at that triangle, do you know the Pythagorean theorem?
Yeah, you know.
Now, let us extract. When you have your triangle, this is C minus X, this is our A, and this is our H, Kasumba. So when you extract it, what is going to be your A squared? When you look at this triangle, C, D, and B.
The a squared will be c minus x.
All of it squared.
Yes.
Then your B?
The B will be h.
H, eh? Which is squared. Then your C?
The c will be a squared.
Let me hope now it is clear.
Yeah, it is clear now. Thanks.
Okay. So members expand. C squared minus. Okay. E. Okay, I think I'm seeing some challenges in expanding. Ruth, can we have someone to expand for us?
Joseph. Well, Joseph. Okay,
Yes.
let's hear from Trouble.
So we put them in, we put it in brackets.
Okay.
C, it's also the same as C minus X in brackets into C minus X.
Okay, very good. Continue.
So that will be, okay, each element in the first bracket multiplies on in the second bracket. So we'll have C into C minus X minus X into C minus X.
Okay, very good.
And then you'll have C squared minus CX
Okay.
minus CX plus X squared,
Okay, good.
which will give you C squared minus 2CX plus X squared.
Most of the time,
when you're in an urban.
Okay. Members, has everyone understood that part? Thank you so much. Has everyone understood up to that
Yes.
part?
Yes.
Okay, very good. Now I'm going to bring this X squared to be close to what I
Mr.
have
Kasiba.
as, yes,
Who?
yes. There is a question. Ruth, do we have a question? Is there any question? Yes, yes. Oh, I don't know, but I'm not hearing. Okay, I think we can continue. So I want to bring this X squared to be close to H. So I want to write H squared plus X squared plus C squared minus 2CX is equal to A squared. Members, is that part okay?
Yes.
Okay. Now, what are you going to notice? This is what you are going to notice. Members, I want you to look very well what you have as your, oh, okay. Okay, there's something I wanted you to see. I want you to look at what is H squared plus X squared. When you look at this only, look at our equation 1. What is that one equaling to? Look at equation 1. Yes, Chidabo?
B squared.
B squared. So where there is H squared here plus X squared, I'm going to put B squared. So I'll have B squared plus C squared minus 2C. Then I ask, what is our X from equation 2? X is B cos A. So I just write B cos A is equaling to A squared. Members, this is what we call now the cosine rule. I don't know the name. Is that okay, members? Yes, Janet. Janet?
Good afternoon, teacher.
Yes, good afternoon.
I have a question about that step of x squared plus c minus x into c minus x equals a squared. Shouldn't it be x squared plus c plus x into c minus x? Because if you work this one out and it forms perfect square, it becomes c plus x squared.
Okay. we start again. You are saying c minus x squared is the same as?
C minus x squared is the same as C minus x into C plus x.
No. Oh, now you are confusing two things, Janet. Janet, is it okay? Janet, don't confuse this. Don't confuse this. This is something different. What you are talking about is the difference of two squares. So those are two different things.
Okay, teacher. Thank you.
Yeah, those are two different. But you first open for us here.
C into C minus x minus x into C minus x.
Continue opening.
Which will be C squared minus CX minus CX plus x squared. That is equal to C squared plus x squared.
What is
minus
C
squared minus 2c squared 2cx plus x squared.
Okay, yes. Now, what you are talking about, you would have been correct if it was c minus x, c plus x. So this is where the difference of two squares comes in.
Okay, sure. Thank you very much.
Okay. Members, are we together on that rule?
Yes, teacher.
Yes. Okay. Can we write? Oh, we have finished writing. Have we finished writing? Or we can?
Just a second.
Okay.
So we are done writing.
Okay. Okay, everyone has finished. Now, I'm going to go back. Okay, sorry, I've stopped sharing a bit. I'm going back, don't worry. I'm taking you back. Yes, I want us now, we are going to derive our own the rules. I want us to draw the generation. Now, when you look at my screen, I want everyone to look at the answer we have obtained. This was our triangle. This was A, and we call this one A. This was B, we call this B. This was C, and we call this C. I want members to check very well that we got A squared, that our rule. Joseph, you can ask. Okay. So members can check well that our rule was A squared is equal to B squared plus C squared minus 2BC cos of A. Members, did you notice that?
Yes.
Yeah.
Now, we are going to generate our rule. Now, in case A comes first, it means you are looking for the length of A. Are we together? And when you start with A, which relation are you noticing with the cos of the angle? Are you noticing that? That the length of the length you are finding corresponds with the angle. And then the rest of these letters keep on changing. Members, I want us to get another law. In case we have B squared, what letters shall we have here?
A squared.
S
A
squared
squared and A squared.
plus
C squared.
C squared.
C squared,
C
good,
squared.
minus
2AC.
2BC.
2AC.
Minus 2AC.
squared
Cos of
plus C squared
Cos B.
So
C
Cos of
squared
B.
cos of
Cos of
2
B.
AB cos of B.
Cos of B.
very good. Now let us derive the last one. What if we have C squared? What shall we have?
A
C
squared
squared
We'll
is
have
equal to B squared
A squared
plus
plus B squared
minus 2
Minus
AB.
2
AB.
AB
AB,
2
Cosine.
AB cos of
Cos of
C.
C.
cos of C. Members, is
Cos of
that
C.
okay?
Yes.
Yes.
Yes, eh? Okay,
Yeah.
very good. Now, we are going to find another thing. Imagine, now this is when you are finding the sides, when they have told you to find the side A, find the side B, find the side C. But at times, like I told you, the cosine rule can also help us to get the angle. Now, when they tell you to get the angle, what does it mean? It means that make one the subject of the formula. And subject of the formula means that that particular thing must remain on its own side. Okay, Patrick, you have a question? Patrick, you have a question? Okay, we can continue. Now, how do we make it the subject? Members know very well that when I have A squared plus B squared is equal to C squared, when I want to make it the subject, it means that on that side, A must be alone. So members, tell me, in case I want to remove this B, how do we remove the B?
Making it cross the equal signs.
So, and when it is
Making
going
it
to
cross
cross,
the
when
equal
it is a
sign.
positive, how does it change?
It
It's
changes to
negative.
negative.
To negative.
So I will say A squared plus
Negative.
B squared minus B squared is equal to C squared minus B.
C squared minus B
Square.
squared.
So our A squared is equal to
C squared minus B squared.
Minus B squared.
Is that okay?
Yes.
Yes.
Now I'm going to come to one of the equations where I have A squared is equal to B squared plus C squared minus 2BC cos of A. Now members, I want you to remove for me this one and we take it this side. How shall it be?
Is
Positive, eh?
square plus
BC was
I will say A
A
squared
squared plus
plus
2BC cos of A
is equal to
B squared plus C squared
minus 2BC cos of A
cos
plus
of
2BC
plus 2BC
cos of
cos of A.
good. Now I remain with A squared plus 2BC cos of A is equal to B squared plus C.
Squared.
Members, remove for me A squared now. I remain with 2BC cos of A is equal to B squared plus C squared
C squared minus
this.
A is equal to B squared plus
Okay. Okay, let me, very good. Now the next thing I'm going to remove is 2BC. So I'm going to divide by 2BC, divide by 2BC. So this and this will cancel. So I remain with my cos of A equaling to B squared plus C squared minus A squared out of 2BC. Members, this is how we shall be finding in case they have given you the angle. Is that okay?
Yes.
Okay. So let's write and then we look at examples. I feel some of you have a poor network. Oh. Some of your network is bad. So let's write. When you finish, you let me know.
Done.
I'm done.
Has everyone finished?
No.
Okay. We give you more time.
Yes, we're done.
Rural areas, some people who live there, they live longer than the people.
Okay. We can now continue. Okay. So we have written that. Now we are going to look at an example. Now, when do we use it? Whenever we are given length of the sides? That is our first question. Now, when you look at our first question, like I told you, whenever you meet these triangles, members first label it such that you can be able to generate the rule very well. So they want us to obtain the length of side A. So we know very well that this is side A. Members, which side is this down?
B.
Side is B.
B, very good. Which side is this?
C.
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 Very good. Can we state our rule? What does our rule say? A squared is equal to
plus B.
B squared.
B squared plus C squared
Plus C squared.
minus 2B.
2BC.
Very good. Now, since we want A, we shall leave our A there, and then we substitute. What is our B? B is
7.
7.
So I'll put here 7 squared. C is
4.
C4.
minus
4.
times 7 times 4
Times 4
of
cos
40.
of A. 48.
Is that okay?
Yes.
So
Yes.
I'll have A squared is equal to. So you deal with these things in steps. What is 7 squared?
49.
49.
49. Plus, what is 4 squared?
16.
16.
Minus 2 times 7 times 4.
14 times
50. Cos of 80. Now, I want to let you know, members, the 56 and the 48, these two things are attached. Never be tempted to subtract. So I'll have now A squared is equal to 49 plus 16. What do you have?
68.
Hey.
60.
68.
Not 65?
68.
65 minus, now 56 times, what is cos of 48? Go to your calculators, look for where you have cos, then you place 48. Which answer do you get?
0.669.
So now I'll come here and I write 0.66913. So now I'll continue and say S squared is equal to 65 minus. Now multiply this. Multiply that. What do you get?
It's
128.
Okay, good. So we shall continue and have S squared is equal to subtract now
128. 71.
27 point. Are we subtracting?
27, yeah.
Point.
Point.
5, 2.
8, 7.
2. Now, how do we get our A?
We square root.
By using the we use the square root.
Okay.
Square
so now,
both sides.
So we shall obtain a square root, So our A will equal to
It's 5.2467 recurring.
which we can write 2.47 centimeters.
No,
So that is our A.
it's 5.246.
No, like 6, It is 5.24678. But this number can be rounded up, so you round up. Hope that is okay.
Yes,
Yeah.
Okay, so let's write.
Oh,
I think, so in case you have any question, feel free to ask.
I have a question.
Yes, please ask.
So my question is, does the number of decimal places you put matter?
Yes, it matters. Some questions, like it will depend on the question, but to be good within the accuracy level, always maintain, at least make sure you write to 3 decimal places whenever they don't specify 3 or 4.
Okay, thank you.
Members, you let me know when you finish and we try out the numbers.
Christy has a question in the chat.
It's asking what.
Yes, Ruth.
His question is that why did we add 2BC and cos A?
Like, why did we add?
To BC and cos A.
Why did we add them? Okay, now the person asking, this is a multiplication.
That's her question. That's what I'm seeing in the chat.
Okay, now this is a multiplication. It's like you're multiplying 2 times B times C times cos of A. So this is one thing. So when you are treating it, you treat it as one thing. So anything you first multiply, like body mass, you first deal with the of. So you first multiply everything, 2 times B times C times cos of A. Before you bring in this subtraction sign, when you look at your body mass, subtraction comes later on, comes on later, but you first start with of. Then subtraction will come in later. So that's why we first multiply before we consider this subtraction sign. Okay. When you finish, we shall continue.
Done.
Has everyone finished?
Yes.
Okay.
Yes, finished.
Okay. Now we are going to try another one. In this one means a triangle ABC. Angle A is equal to 58.3 degrees. Side B is equal to 11 meters. And C is equal to 8.5.
There's also,
yes.
Mr. Kaziba.
Yes.
There's also a question from Alinda again. Joan is asking, when do we drop the perpendicular?
When do we
drop the perpendicular?
When do we?
Mm.
Yes. Now, the perpendicular, we usually drop it whenever we are dealing with a triangle of which we are not sure of which shape is taking on and which angle are inside it. So that's when we usually drop that perpendicular. But the perpendicular, it helps us to find out the shortest distance between any two sides. But we usually use it when we want to find out exactly which sides we are going to consider, and for triangles which we are not sure where it lies. But in case it is the right angle, for it always has its perpendicular. But for triangles whose figures are not clear, whose figures are irregular, those are the ones that we usually drop the perpendicular in order for us to be able to apply the sine rule. But when you are making your calculations, there is no need for you to drop that perpendicular. The perpendicular was to help us to generate the cosine rule. But when you are making calculations, there is no need for you to drop that perpendicular. Just come up with your sketch and that perpendicular will not be needed. But in case you want to put it there, you can easily put there. But the general rule doesn't require you to drop that perpendicular since you have already considered it in your calculations. So our task is, I want everyone to first come up with a good sketch for this question. Come up with your sketch, then we are going to mark. We are going to mark. Yes. So first draw your sketch, and then we mark out. Okay. I think members have finished to draw their sketches.
Sure.
And now I'm going to draw. So I'm going to draw my sketch, and then you compare with the one you have. So feel free to label it the way you want. Like maybe this can be your A, this one can be your C, and this one can be your B. So it doesn't matter as long as you have labeled it below. So angle A, they have told us is 58.3. Side B is 11 meters, and side C is 8.5. Members, have we drawn it like that?
Yes.
Okay. Okay, now let us go on and try to find what our A is.
9.746.
Mm.
9.733. A is equal to 10.0.7.
I can't hear anyone.
I'm saying, please check out. Your answer must be 9.746. In case you are getting an answer different from that, then it means there is something you are not doing right. So Victor, are you getting that answer? Okay. I think, can we continue?
Yeah, we can.
Okay, okay. So this is what I expect. Those who are not getting there, I expect you to have something like this. I expect you to have written your rule as a squared is equal to b squared plus c squared minus 2bc cos of a. Then you went on and said a squared is equal to 11 squared plus 8.5 squared minus 2 times 11 times 8.5 cos of 58.3. Then you go on and say this is 121 plus I think is 72.25 minus 187 times 0.5255. So you ended up with a squared equaling to 193.25 minus 98.269, which gave you a squared is equal to 94.981, something like that. Then after you go to a square root. Okay, now we are going to move on to the next. Oh, yeah, we are moving on to the next. Now the next one is going to be obtaining our angle. Now, imagine they have told you to find the size of the angle. You have been given all the sides and you want to find the size of the angle. So we say that in order for us, and which angle do they want? They want us to find angle A. So what did we say? Our cos A is the same as, which expression did we have? B squared plus
C squared minus A squared
minus
A squared
Okay.
divided by 2BC.
OBC.
Very good. So we shall have our cos of A is equal to, what is our B squared? What is B? I
B is 4.
So I will
B
say
is
4
4.
squared plus C is what?
C
6
squared. C is 6.
6. Minus what is our A?
A
Squared.
Divide by 2 times what is B?
4
Times
6
So I'll have cos of A is equal to, what is 4 squared?
16.
Plus what is 6 squared?
36.
Minus 8 squared?
64.
67.
Out of 2 times 4 times 6?
48.
48. Can we look at the numerators? 16 plus 36 minus 64.
52 minus 64 divided by 48.
50?
52.
Negative 12 divided
48.
And 64 divided by 48.
So 52 minus 64 is?
Negative 12.
negative 12.
Negative 12 out of 40?
8.
Okay, now can we divide? What is negative 12 divided by 48?
Negative
0.25. So I will say cos A is equal to negative 0.25. So how are we going to get our angle?
You press
We get
Shift
what we call
cos negative 0.5.
shift cos.
Shift
So
cos
those,
negative 0.5.
yes, so those who are just new to the calculator, to find cos inverse, place shift, and then you place cos, and then put negative 0.25. You place shift, cos, then negative 0.25. Which answer do we have? Which angle shall we have? Hey,
104.4.
Don't forget the negative 0.25.
It's
104.477.
Okay, 104.5 degrees. Now, members, you are going to get your answer like this. But whenever we are writing an angle, you can write it to not more than 2 decimal places. So you can write it as 480 degrees, or you can write it as 104.5 degrees. Hope that is okay.
Yeah.
Okay. Anyone
Yes.
who is lost? Anyone
No.
who is lost? Okay. Yes, Chilabo Pal. Hannah.
Yeah, I was wondering if you could also, instead of using cos -1, could you also just say negative 0.25 divide by cos?
No, not really. Not really.
Won't it give you the same answer?
Oh, sure. What did you do?
Negative 0.25 divide by cos.
Cos. Why is it mine is giving me an error?
Yes, okay, no, I have not tried it out using a calculator, but ideally to find A, you'd bring cos on this side, and normally we divide. Because
Oh, okay. Now, that one is very true when it is just a variable. When it's just a letter, those letters variables x, y, z. But this one is a function. So there is a difference between what we call a function and a variable. Now, what you are saying is very true. If it was just maybe x, that is very okay. But cos is a function. So you cannot just say A is equal to negative 0.25 out of cos. But now, ideally, what you are trying to do, it can as well work. But now here, the mathematics you need to know is that when you say out of cos, this is a cos power -1, negative 0.25. But this mathematics is not existing. Hope that is okay.
Yeah.
Yes, because the moment you place out of cos, it means you need to put an angle. Otherwise, your calculator will never give you anything if that cos is not defined. Hope Hannah and Carl are together.
Yes, thank you.
Okay. Hope Carl, you have a calculator.
Yes, I do.
Okay, okay. What did you get when you placed it?
Pardon?
What did you get when you placed it?
Which one? Negative
That's
0.25 divide by cos. Syntax error.
Okay, okay. Members, have we finished?
Yes.
I'm putting a number for us to try out now.
Okay.
Okay.
Okay, sir.
Yes. Very okay.
Time.
And you are finding this angle B. So now here I'm testing to see your application of the knowledge. So you are finding angle B. So I want you to try out. Yes. Please members get the answer. And then once you get the answer, yes, calculate. Okay, I want to check on your answers. Some people are saying 73.8. Kasumba Rahima. Let's continue. Okay. 73.77. Okay. Okay. Can we go through it together, or members have figured it out? Can we have one member to describe for us how you have maneuvered to get the answer? Just raise up your hand and you tell us what. Okay, yes, Chilabo Pal.
I got cos B is equal to S squared plus C squared minus B squared.
S squared plus?
Out of plus C squared minus B squared divided by 2AC.
Okay, continue, Pal.
Then I got cos B is equal to 9.75 squared plus 8.5 squared minus 11 squared out of 2 times 9.75 times 8.5, which gave me cos B is equal to 95.0625. Okay, should I just give you the final answer?
Yeah.
Yeah, it gave me cos B is equal to 46.3125 divided by 165.75. Cos B is equal to 0.2794. Then I got B is equal to cos inverse 0.2794, which gave me, okay, I approximated it to 73.8.
Okay, members, let me hope that is what you have. Okay, let me hope now everyone has understood the course. Okay. Okay, members, now I want to see, can we proceed to sine rule? I want to see those who are saying we can proceed, or this is enough for today. Just raise up your hand, those who want us to look at the sine rule.
What?
Those who want us to look at the other second rule. Okay. Okay, I'm just saying there are 1, 2, 3, 4, 5, 6, 7. Okay, there are 7 people. 8. Okay, 8 people. Okay. Okay, let me just introduce it. Those who have not, I think, allow me to just introduce it a bit, like a small bit of it, such that members can have just a hint on how that rule works, because at times they go hand in hand. Okay, let me hope. Okay, now the rule we are going to look at is called the sine rule. And when we are looking at the sine rule, it's not so much different from what we have as our cosine rule. But what matters is, when I'm talking about the sine rule, one, we still drop our perpendicular from C to meet AB. Then we shall have something like that. That is our perpendicular that has been dropped, and I'm going to label it. So you label your triangle the same way you do the other side. You label your side A, label your side B, label it the way. However, now when it comes to sine rule, like the way you hear the word sine, it means that you are going to be using sine Z, not now cos. That is when it comes to a sine rule. So you focus on a sine. Now, and we say that in order for us to get a sine, we said sine is given by opposite divided by hypotenuse. So in case this is my angle A, my opposite is H. My hypotenuse, I'm considering triangle A, C, and D. My opposite is H, and my hypotenuse is going to be a B. Members, is that okay?
Yeah, it's okay.
Now, members, do you agree that H is the same as B sine of A?
Yes.
Those who are not seeing what I'm doing, I have sine of A is equal to H out of B. Multiply by B, multiply by D this side. So you end up with B sine of A is equal to H. Members, now I want to go to triangle C, D, and B. I'm looking at this triangle here. When I look at this triangle, I have D here, I have H here, I have A here, and I have here B. Now I want someone to tell us what is going to be our sine of B. What is our opposite for this triangle?
H.
Yes. H. Out of what is hypotenuse?
A.
A. Now we are going to continue. Allow me to mute you. Now we are going to continue and find our H. So you are noticing that H is also going to be A sine of B. Members, is that okay?
Yes.
Yeah, it's okay.
Very okay. Now, when you look at equation 1 and equation 2, you are noticing that they have the same H, meaning that my B sine of A is the same as A sine of B. Members, is that okay?
Yes.
Now, the most interesting part is here, members. When I divide this side, I want to remain with A. When I divide this side by sine of B, by sine of B, I'm going to remain with B sine of A out of sine of B is equal to A. When I divide this side by sine of A, I say divide by sine of A, divide by sine of A. So sine of A cancels here and here. So at the end of the day, I'm going to remain with B out of sine of B. Oh, sorry. Oh, wait. So at the end of the day, I'm remaining with B. I'm remaining with B out of sine of B is equal to A out of sine of A. And members, this is what we call the sine rule, whereby your B is divided by sine of B equaling to A divided by sine of A. Members, is that okay?
Yes, it is.
Yes.
Okay.
Yes.
Okay. Should we move on? Or you want first right?
Want first right.
Okay, first right. First right. So we have about 10 minutes, so we need to be a bit fast.
Yes.
Is everyone finished? Not yet.
Master, I think we can proceed in the remaining minutes.
Okay. Members, do we agree? We can continue?
Yes.
Yes.
Okay. So that is what we call the sine rule. And members, let's write that general one. Yes. So when you find it being written like this or the other, all of them are right. It is the same thing. So you summarize it.
Done.
Has everyone finished?
Yeah, we are done.
The members finished summarizing?
Yes.
Yes.
Oh.
Are you waiting?
Alinda, why are you crying, Alinda? Alinda.
It's just that only
Yes?
confusion
Confusion where, Alinda?
about the sine rule.
About the sine rule.
Is it like the same? Is it going to be the same as the other cosine?
Oh, no. Yes, they like, no, okay, they are not the same, but they are two different rules. Yes, but it depends on the question and the application. All of them can be used to obtain an angle. All of them can be used to obtain the side. But where does the sine rule apply very well? The sine rule applies whenever, when you have two angles being given to you. There it applies very well. It applies when two sides and an angle has been given. So for it, it has somewhere where it applies, and there's cases where it does not apply.
But how comes in the other rule there is the cosine, there is a cosine, and in this,
Now, like when you hear cosine rule, it means we have a cos. When you hear sine rule, it means you have sines.
there is nothing like a cos.
There's nothing like a cos.
Oh, okay.
So I don't use the Pythagorean theorem in the sine rule.
Now, why? In the sine rule? No, like Pythagorean theory mainly applies when you are when you have right angles. But triangles we are going to be dealing with are going to be triangles that are not that are not right angles. But when you are deriving for the sine rule, you can use, there are very many approaches, but I've just showed you the easy one that we can apply at this level. Yes, but at this level, you may not need to know how to derive. What is very important is for you to know how to use it, how to state and how to use it, and how to apply it when you have been given a question. Now, when you look at this one, when you look at this question, you have two angles being given, and there is only one side that has been given. So for such a case, your cosine rule cannot work for you because you are going to use it and you have two things that are not being given to you, meaning it cannot apply. But whenever you find that two angles are being given and there is a side, it is an implication that you use sine. So now I can use, and I can say A, I don't know. So we are going to apply our sine rule. So I'll have A out of sine of A is equal to B out of sine of B is equal to C out of sine of C. Now, what is important is for you to first identify what has been given to me and what do I want. Now, since they've told us we want side A, and we know very well this is side A, meaning I'm going to use that side. So meaning side A, we can summarize side A has not been given, but angle A has been given as 108 degrees. Then I ask myself, have I been given side B? When you look at our question, do we have side B?
Yes.
Yes.
We have
B?
it. It is 7.
Have we been given the angle B?
Yes.
Which is 108. So now this third one, C.
No, teacher. Angle B is 39.
Oh, okay. Okay.
Yeah.
Angle, this angle B is 39. So when you look very well, you are not seeing that one thing has not been given. And what is that? What has not been given to us is C. So you don't need to use C. So you cancel it out. And remember, whenever it comes to sine rule, you only use two of them. You don't use all of them at a go. You only use two of them. You can either use A and B, or you can use B and C, or you can use A and C. So you can only use two at a go. So now I will come, I have now my rule, A out of sine of A is equal to B out of sine of B. Now where there is A, I put that I don't have it. Sine A, I have 118. I say sine of 118 is equal to B, which I have as 7. Divide by sine B, which is 39. Now I continue, I say my A out of, I place my calculator. What is sine 118?
.883.
Now here you first write to 4 decimal places for accuracy purposes.
Okay.
Divide 7 out of what is sine 39?
0.6293.
0.6293. Now can we divide 7 divided by 0.629?
$11.128.
11.123 Now after we are going to move this. Yes?
It's 11.128. 758.
Sure.
Yes.
7 divided by 0.6293. You get?
Master, is that one?
It's
11.1235.
Okay, 47, which is 5. Okay.
Yeah.
Now, can we remove this 0.829 by multiplying it on both sides? So I'll get A is equal to So in other words, we are multiplying. We have A out of 0.8829 equaling to 11.1235. So you multiply both sides by 0.8829 times 0.8829. So here it cancels and remain with A as
9.820.
9.820.
9.821.
To 1. Okay. And these are centimeters. Hope members, you have picked the idea.
Yes, we have picked the idea.
Yes, sir.
Okay. I think we are not going to go beyond this point. Has everyone finished writing?
Okay.
Yes.
The only thing I'm going to give you is I'm going to give you numbers to try out. I'm going to give you numbers to try out.
Yes.
Okay. Can I stop sharing and I show you the
Excuse me,
numbers?
teacher.
Yes.
I have a question.
Yes, please.
Where we have A out of 0.8829 is equal to 7 out of 0.6293. Can we also just cross multiply and divide?
Perfect.
Okay.
Can I assume everyone has finished writing?
Yes. Yes.
Yes. Okay. Now I'm going to give you numbers to try. I'm going to send in the evening hours in the group some numbers for you to try out, and then you can. At times we want to open the groups, but at times we fear that you people, you can be. There's at times when you find someone jazzing, and others sending some ugly things. So that's why I fear at times that people may send some ugly things in the group. But I'm going to send, in case you finish, feel free. So this work you are going to receive will be of this nature. But now you need to be selective. Which rule are you going to use? So I'm going to first send the work that will require you to use the cosine rule, and you go through it. Then after, I'm going to send the work. I'm going to send you two things. One is going to be about the cosine rule, and another one is going to be about the sine rule. Hope that is okay.
Yeah.
Okay. So we are going to end here. I want to thank you so much. I want to thank I don't know whether Luther's left and everyone for being very active. So we are going to end here for today.